In this video, let us solve this problem. Given capital S is a subset of R3, contains three elements, that is 1, 2, 3 and 2, 3, 1 and 3, 2, 1. So now we need to show that the span of S which is equal to R3. That means we need to show that any element in R3 can be expressed as a linear combinations of elements of these three elements. Okay, let us go for a proof. So, and we know that, let me recall, what is my L of S? L of S, which is equal to, so since it contains three elements, I'll always write this is equal to alpha times 1, 2, 3 and beta times 2, 3, 1 plus gamma times 3, 2, 1, where alpha, beta, gamma are elements in R. So now let us take any element. Let x, y, z belongs to R3. If this fellow x, y, z, if it is in L of S, then we know that there are, I call this alpha, beta, gamma are elements of R such that I'll write this type. Okay, that means x, y, z, which is of the form that is alpha times 1, 2, 3 plus beta times 2, 3, 1 plus gamma times 3, 2, 1 for some alpha, beta, gamma belongs to R. Actually, we need to find what is my alpha, beta, gamma, which express this which represents this my x, y, z. Okay, if that is the case, then what we will have, this side we will have this is alpha plus 2 beta plus 3 gamma. So we will have this is alpha plus 2 beta plus 3 gamma. The second coordinate will be 2 alpha plus 3 beta plus gamma. So we will write this is 2 alpha plus 3 beta plus 2 alpha plus 3 beta and what, okay, actually here it is 3, okay, fine, we will have this is 2 plus 2 gamma. Okay, so here it is factor 2, 1, okay, 3, 2, 1, actually it is 1, okay, fine, no problem. And what about the last term is, that is 3 alpha plus beta plus gamma. Okay, gamma. So we are ended with the system of linear equation which is given by the system of linear equation, that is alpha plus 2 beta plus 2 gamma which is equal to x. The next one is 2 alpha plus 3 beta plus 2 gamma which is equal to y. And the last equation 3 alpha plus beta, actually 3 alpha plus beta plus gamma which is equal to z. So I call this is to be my first equation, and this one is my second equation, and this one is my third equation. So now we need to eliminate alpha, beta, gamma from these three equations. So first what I am going to do is just multiply the first equation by 2. So multiply the first equation multiplied with 2 and subtract it with the second equation. So what we will have, this is 2 alpha plus 4 beta plus 4 gamma, actually What is it? This is 3 only, no? 3 la. So we'll have here 3 gamma. Okay. Then what I will have plus 4 beta. இது ரெண்டால மல்டிப்ளை பண்ணும்போது that is 6 gamma. That is இது ரெண்டால மல்டிப்ளை பண்றேன். அப்ப 2 alpha plus 4 beta plus 6 gamma which is equal to 2x, 2 times x. Now this fellow, second equation. So we will have this is 2 alpha plus 3 beta plus 2 gamma which is equal to y. So now I am going to subtract these two. So what I am having, this will get cancelled and here it will be beta plus 4 gamma which is equal to 2x minus y. So I call this is to be my fourth equation. Okay. Similarly, what I am going to do is the first equation multiplied with 3 and subtract it with the third equation. So what I will have, this is 3 multiplied பண்ணும்போது, so this is 3 alpha plus 6 beta plus 9 gamma which is equal to 3x. The third equation is this, that is 3 alpha plus beta plus gamma which is equal to z. So subtracted, so subtraction. So what we will have, this will get cancelled and here it will be 5 beta plus 9 minus 1. So we will have this is 8 gamma which is equal to 3x minus z. So this I will make it to be my fifth equation. So let us take this 4 and 5 separately. So we will have it is like this. So what I am having, that is beta plus 4 gamma which is equal to 2x minus y. So this is my fourth equation. This is my fourth equation. And 5 beta plus 8 gamma which is equal to 3x minus z. So this is my fifth equation. So fourth equation multiplied with 5. So what I will have, this implies that 5 beta plus 20 gamma which is equal to 10x minus 5y. Minus 5y. Is it okay? So 10x minus 5y. Okay. What about this fellow fifth equation? Let it be like this. So we'll have 5 beta plus 8 gamma which is equal to 3x minus z. So we are going to subtract this. So subtraction. So what we will have? This will get cancelled. So 20 minus 8. So we will have this is 12 gamma which is equal to here 10 minus 3. So 7x minus 5y plus z. So inga minus inga plus iru. So plus z. So we are having this gamma which is equal to, so 1 by 12 times, 1 by 12 times what I'm having, this is 7x minus 5y plus z. So this is my first value, I got it. Okay. Now substitute this in this fourth equation. So I'll make it be. So substitute this in fourth equation. So I call this is to be my 6. Substitute 6 in 4. So what I'm having, this implies that beta plus, so I'll make it be multiply the fourth equation by 12. So that 12 gamma can be easily substitute. So I'm writing this way. So fourth equation will imply, that. So multiply the fourth equation by 3. Multiply by 3. So what you have? 3 beta plus 12 gamma which is equal to 6x minus 3y. So now substitute this fellow here. So what we'll have, this is 3 beta, which is equal to 6x minus 3y minus 12 gamma, which is equal to 6x minus 3y minus 7x plus 5y minus z. So what I'm having, this is minus x plus 2y, this 3 and here plus 2y minus z. So minus z we are having. So beta can be expressed, beta equal to 1 by 3 times, I'll make it be 2y minus x minus z. So this is the second value. So we know what is gamma and what is beta. So substitute these two in where, let us substitute it here. So third equation. So substitute in third. So we are having, so substitute gamma and beta in third equation. So what is the third equation? That is 3 alpha plus beta plus gamma. 3 alpha plus beta plus gamma, which is equal to z, which is equal to z. So which is equal to z. So substitute here. So what is gamma? So we are having 12 gamma will be equal to this, and 3 beta will be like this. So okay, substitute this fellow. So this implies that shall we have a common multiply? So multiply this equation by 3 or something. So 9 alpha plus 3 beta plus 3 gamma, which is equal to 3z. So this implies that 9 alpha, which is equal to 3z minus 3 beta minus 3 gamma. So what is the value here? 3z minus 3 beta will be like this. 3 beta will be like this fellow. Okay. So we are having this case 3 beta, which is equal to 2y minus x minus z. So substitute it here. So minus 3 beta. So we'll have minus 2y plus x plus z minus 3 times, what is by gamma? Gamma is like this. Okay. 1 by 12 times. So we are having minus 3, 1 by 12 times of what else? 7x minus 5y plus z. 7x minus 5y plus z. So we are having 7x minus 5y minus z. Sorry, plus z. So we are having, this is plus z. So we'll simplify this. So what this implies that 9 alpha, which is equal to 3z. So 3z plus z. So I may write it 4z. So we'll have, this is 4z minus 2y plus x minus 1 4. So 1 by 4 times what I'm having, this is 7x minus 5y plus z. So again we are having, so what we'll have, this is this again, so we need to or multiply this with by 4. So what I will have, this is 36 36 alpha, which is equal to, so here multiplied with 4. So we'll have 16z minus 8y plus 4x minus 7x plus 5y and minus z. So what will have, this is equal to 15 z. What will have z? So we are having, this is 15 z. So this and this will get over, and y minus 8 and plus 5. So minus 3y, and here it will be minus 3x. So what I'm having, my alpha, which is equal to 1 by 36. So we can divide it by 3. So probably this will be divided by 3. So we'll have, this is 12. 12 alpha which is equal to 5z minus y minus x. So alpha which is equal to 1 by 12 times 5z minus y minus x. Okay. So this is my solution. So put all alpha, beta, gamma together. So that will give the, so we are having, this is my alpha, and what is my beta? Beta which is equal to 1 by 3 times. So 1 by 3 times what we are having? 2y minus x minus z. So 2y minus x minus z, and gamma which is equal to 1 by 12 times 1 by 12 times what we are having, this is 7x minus 5y plus z, 7x minus 5y plus z. So this is 7x minus 5y plus z. So any element in R3 can be expressed as a linear combination of, thus any element x comma y comma z can be expressed as alpha into 1 comma 2 comma 3 plus beta into 2 comma 3 comma 1 plus gamma into, what is the last element? We will have 3 comma 2 comma 1. So we are having, this is 3 comma 2 comma 1. So this belongs to L of S. Hence L of S which is equal to R3.